Hi, everyone. Welcome to our talk today. We're going to talk about continuous integration and continuous delivery solutions for hybrid and multi-cloud customers. We're very excited to have you here again on day 2 of Next and for sticking with us. Yesterday, if you happen to catch it, we did a talk on CICD for serverless. That was focused on sort of cloud-native, modern serverless applications and infrastructure. This one is sort of kind of the opposite. This one is focused on large enterprises, companies who are living in sort of a world where you have on-prem applications as well as cloud, and you have different services running on multiple clouds, and kind of some of the challenges that may present around developer tooling in those ecosystems. So this is a stat that Urs actually shared yesterday from RightScale. 80% of enterprises are adopting a hybrid multi-cloud strategy. And I think there's a lot of talk over time around like different words around cloud native and tier 1 and tier 2 and lift and shift and all these different terms. And I think the world that we've arrived at now is that this is just kind of the new normal for a lot of different reasons, whether it's cost or control or not really seeing the benefit to moving quite yet. And also sort of leveraging the best aspects of the different cloud providers. Increasingly, enterprises are adopting strategies where they're deploying different services to different places, and there's a lot of challenges between interacting between on-prem resources and the cloud. So what do we mean by hybrid and multi-cloud? It's one of those words, kind of like serverless, kind of like DevOps, that depending on who you ask and what time of day it is, you probably get a different definition. I think the first thing that comes to mind is running applications. So we've had a bunch of announcements so far around GKE on-prem, serverless, things like that. And that's often where your mind goes first. You think about applications. So running Kubernetes on-prem, running Kubernetes on Kubernetes Engine, or running it on other clouds. And for that, if you've sort of looked at Google or been in the space long, you might be familiar with Spinnaker. Spinnaker is our open source multi-cloud continuous delivery platform that we co-develop with Netflix. So Netflix started this. It's what they use for all their continuous delivery. And there are some other talks that are going to be focused really explicitly on this. Target is giving a talk this afternoon that should be really great about how they use Spinnaker to deploy to both their on-prem retail stores and the cloud. And it's really set up for sort of complex sequencing and rollout orchestration. So these are just kind of all the different use cases, though, that often fall under the hybrid umbrella. As we talk to customers and we say, well kind of what do you mean by hybrid? We get all sorts of different answers. So things around multi-cloud deployment, edge computing, invoking legacy dependencies. But for today, we're going to focus on largely the context of CI and continuous integration. So for CI workloads, they look a lot different than running applications, right? They're sort of more batch-like. You have to deal with things like configuration management, peak workloads, multiple platforms, things like that. And what we find is that a lot of companies who have on-prem build dependencies, so things like GitLab or GitHub Enterprise or BitBucket Enterprise or on-prem Artifactory, at build time, you need to be able to securely access these resources so that you can actually build and test your code. The problem is that because these things are on-prem, you need to securely access them, you are now sort of in the business of having to run your own CI server farm. If everything is in the cloud, then of course you can use a cloud-hosted solution and offload a lot of that management and architecture to someone else. But the problem is that if any one of these things, source code, artifacts, other things like databases and license servers are on-prem, then your CI server needs to be on-prem as well. And as we talk to customers, really what they kind of want is something like this. They don't really not want to necessarily have to move their source code to the cloud. They don't want to have to sort of move license servers to the cloud, or maybe they just can't with the way their company is set up. But they would love to be able to offload all of that infrastructure, and that they're investing too many resources in order to scale up to the number of builds that they're running. So we're going to talk a little bit about that today. One of the announcements earlier today, one of the takeaways, I think, is that you can use managed CI with on-prem resources. And we're going to give a demo a little bit later and talk about some new solutions for Google Cloud about how this is possible. If you were at the keynote this morning, you saw one of the announcements that we were really excited about is around Knative. So if you are in the category where you're running workloads on-prem and on top of Kubernetes, this is a new series of open source components that adds a new layer of primitives on top of Kubernetes, one of which is called Knative build, and that lets you, as more of a first-class way, define builds that can run on top of Kubernetes. But for our talk, we're going to focus on how can I offload this all together. So before we jump into that, I want to do a quick little story, and this is going to be interactive. I'm going to describe some of the conversations we had with a customer about their current situation. And if anyone can sort of guess who this is, I want you to please feel free to raise your hand, shout it out, take a wild guess. There are no wrong answers. So this company had a self-hosted CI system, and they had a couple developer teams who were building software. And they were running tests on their local workstation, and they were building software, and that was kind of working fine. But after a while, they were having trouble. They were having inconsistent build environments. They were getting weird irregularities between their workstations, and so they decided, hey, let's set up a dedicated CI server. So they set up a CI server farm. They installed Jenkins or something like that and sort of wrapped it with things like events and workflow. And out the other side, they would have things like logs and build artifacts. And this worked pretty well for a while. And other companies and teams inside the organization said, hey, this is looking actually pretty good. We want to get in on this. So they started saying, could we use the same CI system? And so they joined, and they started sending even more builds. And what happened is that the more builds they sent, they started running into problems, things like bottlenecks, things like queuing. And so they said, hey, you know what, we should get like a dedicated team that can handle this. So maybe it's somebody on the team, maybe it's a new dedicated team, but someone said, hey, you're responsible now for making sure that this thing is working and that our developers can continue iterating on code. And this worked pretty well too, but the company kept growing and the team kept growing, and so they kept sending more builds. And this introduced new issues. They were building all sorts of new different types of applications. So they kind of continued to grow the team. And around this time, they said, you know, this is kind of actually like a formal job, so we should sort of give this team a name. So we called it like the platforms team or the tools team or the ops team, and they were really responsible for building out this infrastructure for their developers. And they said, you know, not only can we actually manage our machines, but we can actually add a lot of value here. So we could do things like provide more logic around releases and rollouts, things like canaries. We can do things like security and analytics so that we can measure things like mean time to release and improve over time. And management said, you know, that sounds actually like a pretty good idea. So we grew that team a little bit. So that kept growing, but the company kept growing. We kept adding more developers. We kept adding more builds. And at this point in time, they said, gee, it looks like we've actually built like an entire CI/CD infrastructure. We should give this thing a name. So we call it the thing like the accelerator or the pipeline factory or something like that. And they sort of productize that internally, present it to developers, and sort of say, you know, you don't need really to think about this. This is kind of our own little internal CI product. So the team grew even more. But what happened is this kind of never ended. The team kept growing, the builds kept coming, and the problem is they never really stop, right? So what we found is that in talking to customers, the number of builds and tests that they're running are actually growing super linearly to the size of their team. So if their engineering team is kind of going like this, because of modern best practices like CI, their build volume is actually kind of going like this. And what's happening is that you're constantly racing against time. You can sort of see the trend line where it's going, and your infrastructure is just keeping up with the amount of builds that you can do. And what we found is that customers are actually doing kind of crazy things. They're actually doing things like throttling the number of builds that their developers run by not adding new features. So they're sort of discouraging builds because the infrastructure can't really handle it. All right, so who was it? Anyone have any guesses? Well, let me ask it this way. Does this sound like any of you here? Yeah, it's everybody. This is everybody. Everybody's gone through this. There's a Googler, he calls this the Rube Goldberg machine builder problem. So if you're familiar with Rube Goldberg machines, we basically keep building machines that build other machines. And it starts innocently enough, right? You're like, oh, I need to run a couple builds. Oh, I need to run a couple triggers. Oh, no, I want to get some metadata. Now I want to do some more workflow. And before you know it, you've reinvented the wheel and you've created a whole CI/CD infrastructure. And yes, Google was absolutely a right answer. We're no exception. Back in 2015, we were running 800,000 builds a day. In 2018, that number is already up to 4 million. Our engineering team has not grown at this same pace. And honestly, this number continues to go up today. And that's because the builds never stop. We don't see this trend ending anytime soon. We have things like now ML workloads and IoT and serverless, and the number of builds and tests are just going to continue to grow faster and faster. So this is kind of the first takeaway of our talk today, is that CI, I think fundamentally, is a compute problem. we tend to think of it as kind of a workflow problem. It's like, oh, if I can write just the right number of scripts and automate them in just the right way, I can run CI/CD. And that's absolutely true. The problem is that you then actually need to run those workloads somewhere. And CI compute looks really different. It's batch workloads, it's configuration management, it's crazy things like nested virtualization. And this has a real cost to it. So McKinsey did a recent study and found that application developers spend a third of their time as system engineers. So this is things like debugging builds, standing up servers. I don't know, has anyone here ever kind of upgraded the version of Jenkins that was running and just completely wiped out their entire system? Yeah, I have. So how can we sort of move past this? So if we look back at our diagram here, a lot of customers that we talk to say, there's a lot of value that we're bringing to our company around kind of the releases and rollouts and the product itself. But this whole middle area of machine management, we'd really love to move to the cloud. We would like to offload all of this and just stop having to think about it. And then that lets us get back to things that really are more important. So things like improving our mean time to release, reducing vulnerabilities, keeping our company out of the headlines with downtime and things like that. So the good news is that we're here to help. And we're introducing this week Cloud Build. So this was announced yesterday. It's a hosted CI/CD platform for increasing developer velocity so that you and your teams can develop more quickly and more safely. So as a brief history, we launched this a year ago as Container Builder. Container Builder was a hosted solution to build Docker images and push them up to container registry in a safe and reusable way. And our vision for this was always a little bit grander. We realized that not only can we build containers using this approach, but we can do things like build tarballs and binaries and run sort of different tasks. And you could point it out a Git repository, set up a trigger so that when you did a Git push, it would automate that for you. With the Cloud Build announcement today, we have a couple of features as well that we're announcing. The first is that you'll notice that this is now top level in the Cloud Console. So if you go to the Cloud Console, under Tools, you'll now see Cloud Build. We added support for first-class artifacts. So the same way you can build and push images and associate that with your builds, you can now build other artifacts like binaries and tarballs as well, and push those up to cloud storage. We also added support for file path triggers, and this lets you filter your triggers based on certain files or subdirectories that have changed. And we have two other features in private alpha right now. They're going to be coming soon. One is a much deeper integration with GitHub. So we're adding native support for pull requests, posting status back to the checks API that they just recently announced, as well as creating triggers programmatically via the API. And the last is a brand new results UI that we demoed yesterday that helps developers debug builds faster and get more of like a dashboard-like view over their projects. So, this all sounds great, Christopher, but I kind of thought the talk was about hybrid and multi-cloud. This doesn't really help me. This is still a cloud-hosted service. I still have fundamental security issues about it interacting with on-prem resources. So today, we're also excited to announce something else. Cloud Build Custom Workers. So Cloud Build Custom Workers is a new feature of Cloud Build. It's in early access right now. It's going to be available soon. And what it does is it lets you securely connect Cloud Build workers to your on-prem resources. So let's take a little bit of a look at how this actually works. So this is my GCP project here. And the way Cloud Build works today is that from my GCP project, I request a build to Cloud Build. Cloud Build then actually runs that build on a worker VM, which is just a Google Compute Engine VM in a shared pool that we manage, and run every build on a new VM. So you send us a build request, we grab one of the VMs from the worker pool, run your build, and then spin it down. And so every build runs on its own machine, so it's completely isolated and secure. The problem is that in an on-prem scenario, you're behind some firewall or private network restrictions. So when that worker goes to access your source code or push to a registry, it can't. It hits the firewall, doesn't have permissions. So that's not going to work. So we're going to do something else. So with custom workers, instead of running builds on a shared worker pool up in the cloud, we're going to run workers inside of a GCP project that you own and control and run builds there. Now, because this is running in your GCP project, you can use VPC or virtual private cloud to connect that project to your private network through peering or sharing. And now that worker can securely talk to and access your on-prem resources. And what's really great is to realize about this is that this is still a managed service. So these workers, these GCE VMs that are running inside your project, you have complete control over. You can access, you can delete, you can configure, but they're completely managed by Cloud Build. So you just tell us how big your pool size you want it to be, what kind of machine type you use, and Cloud Build will still be responsible for delegating builds to it, spinning up new VMs, maintaining that pool, managing the pool size, making sure that it's up, ready, and available. So let's actually see this in action. So we're going to jump over to a demo for a second. Thank you. And so for this instance, we've set up 2 projects in GCP. So the first project is my on-prem project. And inside of this project, I have installed a GitLab instance. So I'm running a self-hosted instance of GitLab where I have my source code and my repository. I then have a separate GCP project for my custom worker pool. And inside of this custom worker pool, I'm going to use VPC peering to set up a secure connection. So this is my network that I've created. It's called my network. And I connected it to my GCP on-prem project. And if I go over to my GCP on-prem project and I look at the VPC network there, we'll see that I've created its equivalent so that now these 2 networks are securely talking to each other. And if I go back to my custom worker project here and look under Compute Engine, we'll see our worker pool. So these are GCE worker VMs that have been spun up and managed by Cloud Build inside of your project. So we should be good to go here. So if I go over to our repository here, so this is our GitLab repo. We have a pretty simple application set up. We have a simple Ruby app. And let's just go in and make an arbitrary change to our Docker file. So I'm going to commit that change. And then if I go back to my project and look at Cloud Build here, we should see that a new build has successfully kicked off. So if I jump in here, this is our build. And we're going to run a few steps here. So these are build steps. This is the Cloud Build convention for running sort of jobs or tasks as part of your build. And if we step through these, we're going to, oh, it's already done. It's pretty fast. Runs on Google Network. We're going to fetch credentials from cloud storage. We're going to decrypt those credentials with the built-in integration with KMS, which is Google's key management service. We're then going to configure Git, do a Git clone to fetch our source code from the repo, and then build our image and push it to the registry. And that all worked pretty well. And the way that we wired this up is we used Cloud Functions to act as a bridge between the source repo event and the actual invocation of the build. So if we go over to Cloud Functions as well in our project, we previously had set up this function. So this function listens for webhook events from GitLab and then runs a build. And so these are the same build steps that we just saw. We fetch credentials, we build the image, and we push it to the registry. And if we go back over to GitLab and look at our integrations, we'll see that we had previously set up a webhook pointing at that Cloud function. So now every time we make a change and we do a push or tag or do a merge event, it'll send that webhook up to our Cloud function. The Cloud function will hear it, kick off the build, and run it on Cloud Build. So that was great, but we haven't actually shown this running on our custom workers. This would roughly look the same if you were running on the shared pool. So let's actually split this out and do these side by side. So this is our worker pool here. And if we jump back over to our project here and go to our functions, let's kick off a few builds and see this happening. So I'm going to run a couple tests. 1, 2, let's say 4 builds. I'll go back to our workers and refresh here. We should see, and sure enough, our builds are running on our custom worker pool. And if we keep refreshing, we should ultimately get to around 4 new VMs. And so what's happening is that Cloud Build has sent the build to one of our GCE workers, and now it's in the background spinning up a new VM to replace it so that the next build that comes in, the VM is pre-warmed and ready to go. And if we keep refreshing this, we'll see this sort of happen over time. And we're up to now, our 4 VMs running. And if we kept going with this, we'd eventually see that it would go back down to 5. As those builds would complete, the VMs would just be picked off. And if we go over our terminal here and do an API response here and hit our Git endpoint for the worker pool, we can see the configuration that we had previously used to set up our pool. So again, this is custom workers. You are in full control and you own this. So this is the project that we had invoked this in. We set our worker count to 5. We're running in multiple regions for redundancy reasons, running on N1 standard 1 machines, and we set up our own private network. Now, I really want to call out a couple of the highlights here, which I think are particularly cool, even outside of the on-prem stuff. So this is all up to you. So we set our worker pool at 5 so that, for the sake of the demo. But this is really subject to your own GCP quota. You can set this to 5, you can set it to 500, you can set it to 5,000. It doesn't really matter, it's going to work. And the other part is machine type. So if you're familiar with Cloud Build, the shared pool that we run builds on are all N1 standard 1 machines, and they're pre-warmed. We do offer 2 higher CPU machines, a high CPU 8 and a high CPU 32, but they're not pre-warmed. So that you have to wait for spin-up time, and usually the beefier machine kind of makes up for it. But we hear frequently from users that they have different requirements. They want a machine with more RAM, they want a pre-warmed compute, they may want, 64 cores, who knows. So you can now completely configure that yourself. So any GCE VM machine type that's available, you can configure for your pool. So you have a pre-warmed pool of any machine type of any size you want that's dedicated just for you and your builds. So if we jump back over to our project here, we're going to show kind of one more interesting thing. So one of the things we hear from customers a lot as well is that, this is great, but I'm not starting from scratch. I already have a CI system set up. I'm using Jenkins, I'm using BuildKite, I built my own homegrown system, something like that. And I'm sick and tired of people trying to convince me that I need to rewrite the whole thing and migrate this whole workload, and I need to do it by Q4. It's just not going to happen. I still have a business to run. So what's great is that because Cloud Build is, it's also kind of a build-as-a-service type solution. It has an API, it works from the Cloud SDK, and you can use it as well from your existing CI setups to simply offload the build infrastructure piece. So we're going to switch to a different project here, where we're using GitLab's built-in CI/CD functionality. So GitLab's really great. It comes with a lot of features beyond just the source repo around continuous integration and continuous delivery. And I want to give a shout out. We worked closely with GitLab on this, so I want to say thanks to Joshua, Priyanka, and Sid, who were really helpful in helping set this all up. But if we go in here and we go look at our GitLab CI file, we can see that we are building a Docker image using what I think is probably the way the majority of users do this, which is running a CI runner, probably a Kubernetes instance running locally, and doing a Docker and Docker build. So for anyone doing Docker builds this way, you're probably aware of some of the security limitations around this. So when you're doing a Docker build, you need access to the Docker daemon, which gives you root access, which is sort of a fundamental security risk in that malicious code can potentially take over your node, break out of the box, and introduce a lot of issues. Now, we get it. This is sort of the way that most people do it because the idea of creating your own pool of isolated VMs and spinning up and spinning down VMs is a lot of work. But if you're doing Docker and Docker, you're aware of kind of some of the latency and security issues. So what we can do with a few lines of code is simply swap this out and offload all of our builds to Cloud Build. So we have a merge request already queued up for this. So we're going to jump over here, and if we look at the code changes that we made, see how those colors showed up, pretty good. We'll see that we removed the steps where we're doing Docker login, Docker build, and Docker push. And we've replaced it with our cloudbuild.yaml file, which is the Cloud Build build config. And we're going to do the same steps. We're going to do a Docker login, Docker build, and Docker push to the registry. We're then going to submit the build using the gcloud build submit command. And what this will do is that this will move the job or the Docker build from our own CI runner that we had to provision and self-manage and over to Cloud Build. So if we go over to our pipelines and run it, and we're on our Cloud Build branch here, this will kick off. What's really great about this is that while this build is running, you'll notice that all the rest of my pipeline hasn't had to change. So all the things that I'm going to do after my image gets built, things like that I'm doing in GitLab, like checking code quality, running container scans and dependency scans, just works as is. So with very minimal change, I've been able to offload a ton of the work and effort that I normally have to do in order to get this set up. So this is going to run through, and if we wanted to jump into as well, we could see the logs here. You can see the steps that are running. We're building the image, pushing the image to the registry. It's successfully succeeded, and this build, if we refresh, should be done, and we've moved on with the rest of our pipeline. And we can see our worker pool is back down to 5 now. And what this lets us do is go back over to our own project and go ahead and actually delete our CI runner that we had previously set up, because we don't need it anymore. It's not our problem. So if we switch back to the presentation, let's just sort of recap what we did. We were able to spin down our own Kubernetes cluster for doing builds, offload that to the cloud, and using VPC, connect multiple GCP projects to a private network, and use a hosted build infrastructure as a service. So what are some of the benefits of custom workers? First, it's managed infrastructure. Cloud Build is managing and provisioning this pool for you, so you don't have to worry about it. The second, I think it's highly configurable. So we showed the API GET call. You can pick your machine type here. You can pick your pool size, even configure your own network settings. And this is just the beginning. Having dedicated pools per customer lets us do a lot of things that with shared pools aren't really feasible. And already from the EAP, we're getting a lot of feedback around possibilities here. So things like caching images, adding persistent disk, letting you cache dependencies on the worker ahead of time as opposed to fetching them during builds to speed up builds. Also things like supporting multiple regions, restricted IP ranges, things like that. So a lot of this is on our roadmap, but it's definitely on our radar and something we're hearing about from customers as of an area of interest. And the last is we should talk about pricing, I suppose. So this is metered billing. And now, again, these are compute engine VMs running inside your GCP project. So you pay for the compute directly. So whatever your current agreement is with Google for how you pay for VMs, it's per minute, and it's just subject to the regular GCE usage. And there's no additional overhead. So you pay for the GCE VMs and storage costs, and you basically get Cloud Build for free. So if we go back to our diagram here, and we sort of look at what our goal was that we were hoping to achieve, we really kind of wanted to do something like this. We wanted our build dependencies to stay on-prem, and we wanted continuous integration to run in the cloud. And I think we were able to achieve that using Cloud Build. And what's really great is that, as we showed, you don't actually have to rewrite your whole entire CI infrastructure. So if you're currently running on-prem CI with something like Jenkins or TeamCity, or you wrote your own infrastructure solution, you can leverage Cloud Build to replace kind of your build agents or your runners in order to offload that compute workload. And because the worker is running in an on-prem network, you can now talk to resources like repos and artifacts. So one thing I do want to touch upon before we go further is how sort of Knative and some of the other on-prem solutions kind of work in this world. So we talked a little bit at the beginning, but this is for people who really want to offload the workload. If you really like the idea of building out your own infrastructure, we definitely recommend using Kubernetes as sort of an underlying component. It deals with a lot of the issues for you, things like auto-scaling, things like caching. And if you take a look at Knative, you'll find some new primitives that make it even easier for you to do that. So if we look at some of our takeaways, two big ones. CI is, I think, at the end of the day, a compute problem. I think anyone here who has to manage it is on the hook for it, knows that you've spent some nights and weekends having to debug builds, having to deal with infrastructure. You can see the trend line and know that sort of you're going to run out of capacity by Q2 next year, and that you need help. So that's what we're here for. And Cloud Build Custom Workers is a really great solution for enabling this. And this is because, again, the builds never stop. So thank you very much. That was the presentation.